Back at it for part two, Colton and Riley again.
All right, so we're doing part two, question two for lesson three. And that question was, what are synapomorphies and why are they so important? So I'm going to explain to you what a synapomorphy is real quick. So pretty much what a synapomorphy is, I'm kind of going off the book definition because that's how I like to say it. I like how they said it. So it's pretty much a derived character, which means this character isn't coming from a common ancestor. So it's when one or two different species or lineages of species develop a derived character that they got from the most recent common ancestor within their population. So kind of like show you the contrast, like a homoplasy is when two or more species have two of the same derived, they both have the same derived character, but it's like split apart. It's not, they don't have any common ancestor. They don't have a recent common ancestor before they split and got those derived characters. But we have a little screenshot here that we'll see if we can show you. Let's see. Awesome, so here we go. So right there on the bottom left of that thing, you got your synapomorphy. So as you can see, like where it branched off, where one ancestor branched off into two new lineages, you can see that that's where the derived character was developed, and you can see that both of the new species took on that derived character. And in comparison to a homoplasy, they don't have a most recent common ancestor, and the derived character popped up a lot later in their lineages. So that's kind of like the difference.
Yeah, and you can see kind of from this picture too why synapomorphies are really important. And the biggest reason is because they allow us to be able to, they're really the base block to how we draw a phylogenetic tree. And so a synapomorphy, as we talked about, shows those common ancestors, but it also shows where those derived traits are coming from. And it's important to note, like as Riley said, that there are two or more. So that's how we can actually get groupings and branching in our trees, which is why they're super important for us to be able to draw those trees and see where common ancestors and where the current species derive that trait from. So
yeah.
So back to.
So yeah, pretty much like Colton said, like it pretty much helps us to be able to help group our species. So when you've got kind of like what our homework assignment was, when you've got A through J, if you can notice synapomorphies, like based off of like what characters are shared between certain taxa or certain species, you can know that, oh, if that's a synapomorphic trait and between taxa I and taxa J, obviously those are going to be right next to each other, and they're more than likely going to be branched. So it helps you know what order your species is in.
Yeah,
That's
so
it.
guys.